U.S. Department of Agriculture is now authorizing loans to farmers for construction of on-farm storage facilities for high-moisture grain and grain silage. And to discuss that new loan program, with us today we have Dean Spearman of the Agricultural Stabilization and Conservation Service. And Dean, we've had farm facility loans in the past, but how does this differ?
Well, Larry, on July 20th, the department announced that they would authorize loans for high-moisture grain storage. And what we simply did was to add loans for high-moisture grain or grain silage to an ongoing existing program. And this should be of prime benefit to livestock and dairymen who need high-moisture grain facilities to store their corn, high-moisture corn or other grains, or grain silage.
Why did we initiate the Farm Facility Loan Program in the first place? It's been with us for about 30 years, hasn't it?
Yes, it has. For example, the first loan was made back in 1949 when we felt that the department did that grain growers needed some on-farm storage facilities to store their grain. And since that time, the program has been expanded to cover farm storage facilities for other grains and other commodities and for drying equipment.
What are the terms of these loans?
The loans are actually scheduled for repayment in 4 annual repayments over 5 years. So in effect, what we have is a 5-year term loan.
Does a farmer have to make a certain down payment to qualify for a loan like this?
Yes, there are eligibility requirements, and one of the requirements is that he make a minimum of a 15% down payment. And this was just changed recently. Prior to April 1, the down payment requirement was 30%, but now it is 15%, which is surely more attractive.
And what is the current interest rate for these loans?
7%.
How about the maximum loan limit? Is there a top level that you loan?
Yes, the level currently is $50,000, and here again, prior to April 1, it was $25,000, but the department increased that to $50,000. Our loans are actually based on 85% of the net cost of the storage or equipment to the farmer, with a maximum loan of $50,000.
Dean, can these farm facility loans be used for purchases of drying equipment or other related facilities to grain storage?
Yes, we make many loans for drying equipment. On any one application, a farmer may obtain a bin, a continuous flow dryer, an in-bin dryer, a batch dryer, and what we call operating equipment. By that we mean equipment to move the grain or commodity in and out of the structure.
What about the electricity and foundations and this type of thing? I think in the past they weren't included in these loans, but are they now?
Currently, yes. In other words, the cost, concrete cost, and the cost of electrical wiring, the labor and materials can be included in the amount of the loan.
And if you'd like more information about farm facility loans, either for wet storage or for dry grain storage, contact your local office of the Agricultural Stabilization and Conservation Service. Thank you, Dean Spearman, for being with us. I'm Larry Quinn with the U.S. Department of Agriculture in Washington. American wheat farmers are preparing now to plant the 1978 winter wheat crop. Harold Owens is an agronomist with the Extension Service of the U.S. Department of Agriculture, and Harold is with us today to talk about some of the important considerations for farmers as they plan for this next year's crop. And Harold, how does a farmer go about choosing the best variety that he would plant?
Larry, the farmer wants to choose a variety that is adapted to local soil, climatic conditions, that will produce a grain that will be suitable for the market that he is producing for.
Is there local test variety test information available that he could consult?
Yes, the states conduct yield trials, and these reports are available at the county extension offices and experiment stations.
Once we've chosen a variety, we still do need to pay some attention to quality of the seed, don't we?
Oh yes, you want seed that is as disease and insect resistant as possible. You want it to test high in germination, 85% or more, to be of high test weight, 57 pounds per bushel or more, and be a plump kernel. Those are some of the things you want to have.
What if you ended up with some shriveled wheat? Would this contribute to your problems in getting a good stand?
Shriveled wheat, even though it may germinate, will produce a poor sprout and plant and possibly die.
What about the farmer who chooses to replant some of the seed that he has harvested this year? Should he carry that wheat through some special preparation process?
The wheat that comes from the combine is seldom ready to plant. It usually needs at least cleaning and should be checked for purity, free from weeds, and of high germination.
By now, many of the farmers have already done a lot of their seedbed preparation, haven't they?
Oh yes, they have. And of course, the farmer wants to end up with a firm, moist, mellow seed bed that will germinate and grow the wheat.
Does he usually start preparing right after the previous year's harvest?
Yes, because you want to do the things that will conserve moisture and also gather the plant nutrients in the soil, because they'll become available if they have a longer period of time.
What about fertilization for growing wheat?
You want to supply all of the nutrients in appropriate amounts that will produce high yield of wheat, and of course the soil test is one of the best methods to determine the amount of fertilizer that is needed to supplement what's in the soil.
Actual planting time can be very important, related to the moisture supply in the soil too.
Oh yeah, it's necessary to have moist soil that be in contact with the seed so that it will germinate and grow.
Harold, of course, many of the wheat-growing states are out in the Great Plains, and moisture has been a problem this year, so it's going to be very critical in terms of the decisions they make this year. Thanks for being with us to talk about wheat planting decisions that we need to make now for the 1978 winter wheat crop. Harold Owens of the Extension Service. I'm Larry Quinn with the U.S. Department of Agriculture in Washington. Wheat is the primary crop in the Great Plains states. Last year, almost 42 million acres, about 60% of the nation's total wheat acreage, was planted there. But Great Plains wheatlands are vulnerable to wind and water erosion. Harold Owens is an agronomist with the Extension Service of the U.S. Department of Agriculture, and he's with us today to discuss conservation tillage for Great Plains wheat. And Harold, tell us about conservation tillage, what it is and why it is important for those wheat-producing states.
Larry, conservation tillage is any soil management practice that will leave the surface of the soil resistant to erosion and at the same time conserve moisture. The reason it's important, particularly in the Great Plains, is that the climate is quite variable and cyclic in nature. Wet periods are followed by dry years, which you get severe wind erosion. And this, of course, makes it important to conserve plant residue on top of the soil in order to resist this.
Let's take a look at some of the different methods of conservation tillage that are utilized.
Of course, the farmer, wheat grower, wants to arrive at with a firm seed bed that has plant residue on top to conserve the moisture and resist the wind erosion. Now we can look at, this is the chemical fallow, which is using the herbicide to control the weeds and
not even tilling it at all.
That's right. You don't have to till it and resist the. And then we have the deep furrow drill, which plants the seed in a furrow, and this leaves it in a condition that is resistant to the wind erosion. You notice there's some straw sticking out, and this compared to a field that is rather bare and been bare fallowed, and you see it has severe wind erosion on it.
How do you arrive at the first situation we saw there, where you leave a little bit of the straw on the surface of the soil?
You use tillage implements depending on the amount of stubble that is present when you start the fallow period. If it's heavy stubble, you use either a disc or that is an offset disc or a tandem disc or a one-way as a tillage implement in the first operation. Now if it's a medium to a light stubble, well then you use a chisel or subsurface implements to do the tilling.
How much residue should you leave on top of the soil, Harold?
The amount on sandy soil is you need about 1,700 pounds per acre of plant residue. Now for silt loam and clay soils, why, it can be less.
So even your previous year's crop could affect how much straw would be available to leave on the top of the soil.
Yeah, that's the first thing that you look at, is how much you have to start with.
How does conservation tillage affect the yield?
In general, the yields are equal or to better compared to the moldboard bare fallow conditions.
So what are the advantages to a producer for using it?
The advantages are that you, of course, can get the higher yields. It's possible too. You can save water, you can prevent erosion, and you can cut energy requirements.
And if you'd like more information on this, we have a booklet that we can offer, Conservation Tillage. If you'll write us here at Agriculture TV, Washington, D.C., 20250, we'll send you a copy. I'm Larry Quinn with the U.S. Department of Agriculture in Washington. Department of Agriculture is seeking practical ways of using solar energy in rural homes. Jack Cox of the Rural Development Service of the U.S. Department of Agriculture is with us today to talk about some of the demonstration projects that are now underway. And Jack, what is being done by your agency to explore some of the practical implications of solar energy for rural homes?
Well, Larry, our long-term objective, of course, is to assist in saving energy in rural areas. We have several different demonstration projects going at the present time showing that solar energy is practical in rural homes.
Tell us about a couple of the specific projects that you have going on. I think you have one in Arizona.
Yes, Larry, we have two projects really and two locations really in that one project. We have one location in Arizona and one in South Dakota. It's a joint project with the Rural Development Service and the Energy Research and Development Administration. Our effort there is to show that a solar energy unit can be used on a farmer's home type house, say a house from 900 to 1,100 square feet.
And a low to moderate income type house.
Oh yes, low to moderate income housing.
What are you using it for? Heating water or heating in the home? Just what?
The Arizona house, the Arizona project is on a farmer's home house, which is designed to heat both water and to provide a significant portion of the heating load in the actual house. The project in South Dakota is just home heating.
What about the designs of solar energy units for rural homes? Are you doing anything in the area of actually coming up with a practical design?
Yes, Larry, we are. We're working on a particular design right now to assist in saving energy in rural areas. We're very excited about this one particular design. We're hoping to be able to test that one this winter.
Now, you're working with the Agriculture Research Service, I understand, too, who has been doing some research in solar energy across the board, but also looking into some of the methods that they are recommending to see if they're practical.
The Agriculture Research Service has been involved in solar energy projects for quite some time. And we've provided them with a little bit of support, and they're running two projects for us now down at their rural housing unit at Clemson University in South Carolina. We're very encouraged about those two projects. They show some definite positive results.
And I guess when we mean practical, we also should add to that, or should mean, cost effectiveness. A lot of people have felt that solar energy has not been cost effective up to now, and perhaps especially for low to moderate income housing. Do you see it as being practical now or in the near future?
Well, Larry, 5 or 6 years ago, solar energy to heat hot water was, in your words, was not cost effective. Now it is. It's really cost effective right now to heat hot water for homes with solar energy. And presently, that's the case. We're in the position now of seeing that in the future solar energy will be very cost effective for heating homes as fossil fuels, petroleum, gas, oil, etc., become more expensive.
And some of the things Rural Development Service is doing will hopefully lead to that. Thank you, Jack Cox of the Rural Development Service of the U.S. Department of Agriculture, for being with us. I'm Larry Quinn with the U.S. Department of Agriculture in Washington.
The Department of Agriculture's Soil Conservation Service is currently undertaking an inventory of windbreaks or shelter belts in the Great Plains states. My guest today is Bill Lloyd with the Soil Conservation Service. Bill, what's the purpose of this inventory?
There are two purposes to the inventory, Don. One purpose is to fulfill an obligation that we have. The General Accounting Office has told us to make such an inventory. A more basic reason, however, is to obtain some factual information on how many windbreaks are being removed and why they're being removed and how serious this is to our windbreak resource.
Farmers and ranchers have long understood the value of windbreaks. Why would they be removed?
Well, there are many reasons for removing windbreaks. One of the principal ones, and this slide shows it very well, is sprinkler irrigation, pivot sprinkler irrigation. You notice those green circles, and those of you who've flown over irrigated areas will have seen the green circles down there. The water source, the well perhaps, is in the center, and the sprinklers go around and make a circle. Well, obviously, a windbreak in there is incompatible. You cannot have a windbreak in there and make the sprinkler system work. Now, of course, it's not all lost. You'll notice those nooks and crannies between the circles.
Now,
And
is that lost area? Is that dead area that can't be
no,
cultivated?
it isn't. It's lost in part to the man who wants to grow wheat or corn or whatever it may be, but it's not totally lost because lots of people are planting trees and shrubs to give some windbreak protection.
In many cases, these irrigation systems can be several hundreds of feet long, too, right?
Yes, in fact, a typical one is a quarter-mile long.
Okay, Bill, what are some of the other reasons why windbreaks would be removed?
Well, one reason, if every agricultural census shows us that we have fewer farms than we had the last census. Farms are being combined, and as farms are combined, there are farmsteads abandoned. A windbreak then that was in a logical place before no longer is in a logical place. It may be a barrier to movement of equipment and so on.
Now, you just completed a pilot survey. What type of indication do you have now as far as the removal of these windbreaks?
Of course, the purpose of our pilot survey was to find out how best to do the job. But we found out two things very clearly. One was that farmstead windbreaks are not being removed. People are keeping them very, very well. Field windbreaks are being removed, and our survey showed that about a rate of 1% of the area of windbreaks each year. And that is fairly critical. Now, that was only a small study, and we'll have to wait till we get the facts.
So where do we go
major.
from here?
Well, we need to know, of course, what the facts are. And when we know the facts, if it is a serious matter, then we will need to build a program, beef up programs or build new ones, because we recognize the social values, the community values of windbreaks, that the people off the land are as much concerned, or perhaps more so, than the man owning the land.
Thank you very much. Bill Lloyd with the Soil Conservation Service, taking a look at windbreaks. I'm Don Elder for the Department of Agriculture in Washington.